Dear students, welcome to another video tutorial on data structure and algorithm. And today's topic is linked list deletion and traversing. Myself Niladri Shekhar Pal. I am working as an assistant professor at Computer Science and Engineering Department at Greater Kolkata College of Engineering and Management JIS. The college is situated at Baroipur. So let's check how a node can be deleted or how first node of a list can be deleted. Okay, so the step one is copy the address of the first node. Okay, that is head node to some temp. Okay, variable say to delete. Okay, so as you can see, the copy of the address of first node, that is this is the first node, and the address, okay, will be copied, that is head node to some temp variable say to delete. Okay, so there is a variable to delete and we have copied the address of this first node there. Next one is move the head to the second node of the linked list, that is head will be head next. Okay, so head will now point to this 20. Okay, so head is now. Okay. So the next one is disconnect the connection of first node to the second node. Okay, so we have deleted the next part of first node. Okay, so that this connection has been lost. Okay, so this is how we can delete our first node from the linked list. Free the memory occupied by the first node. Okay, so we will completely delete this node. Okay, so that the memory will be free. Okay, so I will seeing you once again what happened. Okay, so this is the linked list. Okay, so we'll first copy the address of the first node, okay, of 10. Okay, and we will save it to the to delete variable. Okay, so after that we will move the head to the second node. Okay, that is head is now from here to here. Okay, so now we will disconnect the connection. We will disconnect this connection and we will free the memory. We will completely delete the node. Okay, so that the memory will be free now. Okay, so now we will do a program to delete the first node from the linked list. Okay, so let's see how to do it. Okay, so first we will take the header files. Include. Okay. Next hash include Kanaya.h. Okay, next we will take the global variable node, struct node. Okay, next int data, struct data, sorry, struct node. Okay, point to the next. Okay, so there every node has two parts. One is the data part and the next one is the head part. Okay. Next part. This is the head. Okay, this is the head. Okay, now we'll declare the functions which are required. At first we will create the list function. Okay, so for that we will have to pass the number of nodes. Okay, next we will do the void delete first node function. Delete first FIRST for delete first node. Okay, after that we will call the void display function. Void display list. Okay, so these are the main three functions. Next we will start the int main. Okay, this is the int main. We have to take variables int main, suppose choice. Okay, next we will printf enter the total number of nodes. Okay, enter the total number of nodes. Scanf percentage d comma ampersand n. Okay, so we'll call the create list function now. This is the printf. So data in the list. Okay, we will now call the display function. So this is the display list. Okay. Next we will call the delete function printf. Press 1 to delete first node. Okay. Scanf percentage d comma ampersand choice. Okay. So if the value of choice is equals to 1, okay, we will call the delete first node function. Okay. We will call delete first node function. Okay, delete first node function. Okay. So after the if loop, we will printf the data. Okay. Slash in data in the list. Okay, data in the list. So we'll again display the linked list. Okay. Okay. Now we'll define the functions one by one. Okay. So just return 0. Return 0 is there. Okay. I will just call one by one the functions or define all them. At first the void create function, void create list. Okay. So maintain. Okay. So struct node, new node. Okay. These are the variables too of node type. Okay. Next we will take another variables in data comma I. Okay. So if head equal null, okay, we can say that. Sorry, I first will to define the head. Okay. So head will be struct node pointer malloc. This is size of. Okay, size has been defined. Okay, struct node. Okay. Now we'll call check whether head is null or not. Okay, so head is null. Printf unable to allocate memory. Okay, I will be less than n because we can insert maximum n elements. Okay, so I is less than equals to n. Okay, so I plus plus. Okay, so we will create the new node each time. Okay, so this is struct struct node, okay, pointer, this is malloc, size of struct node, if new node equal null, okay, so we can say that the printf unable to allocate memory, okay, this is the break statement. So in the else part, printf version, enter the data of node percentage t, okay, the value is scanner percentage t, percent data. So new node equals new data, next part will be the data, okay, and new node next part will be as usual null, okay, so next will be null, will be data here. So the new node have two portion, one is data portion and one is the next part. In the data part the value will be inserted and the next part will be null, okay. So temp next equals to new node, okay. Okay, so now the temp will be temp next, okay. So this is the part for creating the list, okay. Just printf the slash n that the link has been created, okay. So the linked list created, okay. So now we'll write the void delete function, delete first node, okay. Delete first node, okay. So struct node pointer to delete is a variable, okay, as we have discussed. So if head equals to null, then there is no question of deleting anything, okay. So we'll printf that the list is empty, okay. So list is empty, okay. So in the else part we can write that to delete equals to head, okay, and head equals to head next, so printf, so deleted data equals to percentage d. Value will be 2 deleted. So after deleting, we will see the variable. Okay, so that there is be no space occupied. Okay, now we'll just print it that we have already deleted it. Okay, so slash n successfully deleted first. Okay. So next one we'll define the display list function. Okay, struct node pointer 10. Okay, so if head equal null. Okay, so the printf we can say that list is empty. In the else part, we can say that temp equals to head. Okay, and while temp not equals to null. Okay, we can say that printf will print the elements. Okay, comma temp data. Okay, will be okay, and the temp equals to temp next. Okay. So this is the function for display. Okay, so let's save the program first. Save it as okay. So this is the function for delete first. Okay, so it is in list delete okay. So we can now run the program. Okay, so there is an error. Let's check the error is basically the error is what is at top level. Okay, so the error is okay. So let's run the program. So total number of is supposed 4, value is supposed 2, 5, 8, 9. Okay, so you can see that the link list. Okay, press 1 to delete first node. Okay, if I delete, you can see that the 2 has been deleted. Okay, so this is the program to delete an element for the first element from the node. Okay, so this is the program to delete the first node from the linked list. Okay, so now we will discuss another one. Okay, so delete last node from the linked list. Okay, so before this, traverse the list node. Okay, of the linked list, keeping track of the second last node in some temp variable, say second last node. Okay, so this is the second last node and this is the last node. Okay, this has been defined as second last If the last node is the head, okay, then make the head node as null. Okay, this is not the head node. Okay, else disconnect the second last node with the last node. That is second last node next equals to null. Okay, so what we will have to do? We will do the second last node next as null. Okay, so this connection will be break. Okay, so as you can see that this connection has been break. Okay, so now we have to free this node. Okay, so free the memory occupied the bus. Okay, so now I will do the C program to delete the last node from the linked list. Okay, so let's write the program. This is hash include stdio.h. Okay, next hash include canaya.h. These are the header files. Okay, next we will declare the node. Okay, this is the global variable. So it has two part. One is data part and one is the next part. Okay, so struct node point to next. Okay, this is the head. Okay, now we'll call the functions one by one. Okay, declare the function. The first one is create list as the previous one. Okay, we will pass the number of nodes. Okay, here. Next we will void delete last node. Okay, next the display function. Okay, so next int name. Okay, so this is the main function. Okay, I am taking it from the previous program. Okay, so this is the display. Delete first node, instead of it will be last node. Okay, and the function will be last node. Delete last node. Okay, okay. So now we have to create the display list. Okay, this is the if, this is the return 0. Okay, so now we'll call one by one functions. Okay, so the first function will be void create list. Okay, okay. So this is the function for create list. Okay, as we have discussed earlier in the program. Okay, so this is a function for create list. Okay, next we will define the another function, that is display a delete last node. Okay, so void delete last node. So struct node to, to delete. Okay, second delete second last node. Okay, if head equal null, printf list is empty. List is empty. Now go to the else part. The else part it is okay. So in else part there is a variable that is to delete, okay, equals to head. Next second last node will be equals to head also, okay. So while to delete, okay, while to delete next not equals to null, okay, you can say that second last node equals to delete, okay. So to delete equals to delete. Okay, so if to delete equal head, we can say that head equals to null, else second last node equals to next equals to null, okay. Now we have to free the so printf successfully deleted last node, okay. Okay, now we'll call the void displayList first function, okay. So now let's run the program. I am copying the display list function from the previous program. It is same as the previous, okay. So let's save the program first, that is last delete last node, okay. Linked list delete last delete last, okay. So compile and run, okay. Suppose the number of node is 4. I am inserting one by one 76, 90, 56, okay. So I am pressing 1 to delete. As you can see, the last node, that is 56, has been deleted, okay. So this is the program to delete the last node of a linked list. So students, hope you have understood the programs, okay, linked list deletions, okay. So if you have any doubt, any query, you can write on the comment section, okay. Or if you have liked my video, you can subscribe to my channel. Or if you can visit www.facebook.com/digitalclassroom okay, and like my page. So students, thank you for now. See you in the next video tutorial. Thank you.